You are now ready to design schematics on Cadence Virtuoso EDA tool. Now, this is the command interpreter window that we've opened in the previous video. Every time you invoke Cadence Virtuoso, it is best to exit it entirely before logging off the server. This is going to make sure that there are no locks on your files, that you make them inaccessible for edit the next time you open Virtuoso. Now, this is the overall design flow that we will be following while we design our inverter schematic. The first thing is we decide on the design specification that we are going to implement in our schematic. For example, width and length of the FATs that we'll be using. Once you have all the design specifications ready, we are now ready to design the schematic based on its circuit. Once you've designed the schematic, you save and check for any errors, and if there aren't any, you proceed and create the symbol for it. Once you've created the symbol, you can use the symbol as an instance and create a test bin schematic, which you can then simulate and check whether your schematic is actually correct or not. Once you've made sure that your schematic is perfect, you can go for the layout design, which is basically laying out the transistors physically. And then you can run checks called DRC and LVS on it to make sure that your layout does not have any errors in it, and then simulate it to make sure that the design requirements are met. In this video, we'll be doing the first two steps, that is designing the inverter schematic and creating a symbol for it. To design the inverter schematic, let us first open the library manager window, which you can open from the tools button on the command window. And in this, you can already see that there are some predefined libraries that have been preloaded into the library manager window from the model files that we've copied into our 22234 directory. The GPDK45 is the 45 nanometer process node that we're going to be using to build the inverter schematic. Now, to create a new library in which you are going to design your schematic, I'm going to use the keyboard shortcut Control-N that opens this window. And I'm going to give it the name project_1 and press OK. And it's going to ask you if you want to attach this particular library to an existing technology library. Since we've already loaded the GPDK 45 nanometer into the library manager, we can select attach to an existing technology library and press OK. And you can choose GPDK 45 from this. And here you can see that your new library has been added to this list, and it does not have at the moment any cells or any views. So now to open the schematic editor window in this project, I'm going to add a new cell view in this from File, New, Cell View. And I'm going to choose the view of a schematic and name my cell Inverter and press OK. And now you can see that an inverter cell view has been added to the project library with a view of schematic. At the moment, that is the only view that we have. In the future, we can create other cell views for it, like a symbol or a layout. And right now the editor window has opened and it is blank. We can now start designing our inverter schematic. If you recall, a CMOS inverter has one PMOS in the pull-up and one NMOS in the pull-down networks. So the first thing I'm going to do is create those instances by pressing this little button right here. And since my MOSFETs are in the GPDK 45 nanometer technology, I'm going to choose that particular library and choose NMOS from the drop down. Now, as you can see, there are a bunch of NMOS varieties that you can choose from, but these are high voltage and low voltage and 3-terminal MOSFETs. Whenever you can, try using the 4-terminal one so that you can vary the bulk voltage to see how the MOSFET performs. Right now, I'm going to use the plain old NMOS 1 volt. 1 volt is the VDD for the 45 nanometer process. And this is a 4-terminal NMOS device in the 45 nanometer technology. In the similar manner, you can also add a PMOS 1 volt, for which I'm going to change the width to be twice the width that I've used for my NMOS. Now this is to compensate for the low mobility that is there in the PMOS FETs due to holes being the majority carriers in them. Now I can place my PMOS on the top and press escape. Now I have my FETs ready. The next thing I want to do is give the supplies. So for that, you can do that using 2 ways. One is from an analog instance and the second by giving a pin. Now in a chip, there is huge noise and sometimes there is a VDD bounce or a ground bounce, for which you would want to simulate and check the capacity of your circuit. And for such places and such situations, you would want to use a pin for giving the supply voltage and simulate how the circuit works based on the signal that's given as VDD. So I'm going to use both of them right now just to see how it works. So firstly, I'm going to instance it, and I'm going to instance ground from analog library GND. You can move these around by pressing a keyboard shortcut M, and I'll place it right here. So for now, I'm not going to instance VDD because I want to create a pin for the supply voltage. And you can use the keyboard shortcut F to fit your circuit to screen. The next thing we do is give pins. So since we just discussed supply voltage, I'm going to do that first. And I'm going to name my pin VDD, and it is an in-out pin. So open the drop down and select input output and signal type as signal and place it in the schematic. I'm going to move this around and place it right on top. Now my supply pin is already ready, and I can now give my inputs and outputs. So for my input, I'm going to give the pin name IP and choose the direction as input. In a similar way, I'm also going to give OP as output pin. Now my pins are ready. So once you have made sure that all of your instances are in the schematic, you can now start connecting these instances using a wire. So for that, I'm going to use the keyboard shortcut W, or I can go into create and wire. So now I'm making the connections of the inverter based on its circuit schematic. And I'm going to move the components around to make the circuit more compact. And make sure that there are no floating terminals left on the schematic. And I'm going to connect the bulk terminals of the CMOS and NMOS to the respective terminals. And once the schematic is ready, I can check this little guy right here that says check and save to see if there are any errors. So since right now I just clicked on check and save and there was no error window that popped up on my screen, it means that there are no errors in my schematic. You can also check that using the command window where it says schematic check completed with no errors. And once this is done, I'm ready to move on to create the symbol view for my inverter. So to create a symbol for the inverter schematic, so now I'll press create and check cell view and press from cell view. This is going to open this particular window in which you can see that the view that you're going to be going to is a symbol. And the cell name, I have kept it inverter and I'll press OK. And as you can see from the schematic, the pins have been sourced and the left pin is input, right pin is output, and the top pin is VDD. So these all seem okay. So I'm going to press OK. And it's going to open the symbol editor window. And it's going to give you a sample symbol, which you can edit as per your convenience. I'm going to delete all of this. And firstly, I'm going to rename the part as inverter and give the instance name as I1. Now the instance name is going to be I1 here, but if you use multiple copies of this instance in your further schematics, it's going to rename the instance name by itself. And I'm going to use the keyboard shortcut R to turn this and use these on the top to create my symbol. So while designing, if you think that the smallest component in distance that you can move is very huge, you can always press O on the keyboard and you can edit the snap spacing here and make it lesser so that you can move by smaller spaces in the schematic editor. So now my symbol looks ready for use. And I'm going to do the same thing that I've done with my schematic and press check and save. And as you can see, there are no errors. That means that I've successfully created my symbol to instance the schematic that I've just created. Also, make sure that the pin names that you're using here in the symbol are the same as the pin names that you've used in the schematic, because essentially they are the same component. So their pin names should also be the same. So this concludes the schematic and symbol design for your inverter.